In the previous lesson, we learned residence diagramming method, the PDM, within the critical path method, CPM. And in that lessons, we did not consider the lead lag factors, and the only one dependencies that we focused on in that lesson is the finish to start. It means that one activity had to be completed before the other activity, the following activity, to start. But in the real life, there are other dependencies between the activities, and actually there are 4 of them that we can have. Finish to start, that's something that we already focused, and it stands for FS. Finish to finish, it stands for FF. Start to start, SS, and start to finish, SF. And for start to finish, it's not practical in engineering, so that in this class, I don't consider that a relationship in our class when we model the project schedule. So only focus on the first 3 dependencies, which are finish to start, finish to finish, and start to start. And the other factor that may include in the schedule that is lag and lead. And by definition, the lag, as its name implies, the amount of time, so it's about time, an activity follows or is delayed from the start or finish of its predecessor. And lead, just opposite, the amount of time that an activity precedes the start or finish of its successor. So with that definition, before I go to slide to have some visualization, I give you an example of the dependencies and how the lead lag is all about. So let's give you an example here about the finish to start, so FS. Example, when you do the design, first you need to do the concept design, and it needs to be completed and approved before you do the detail design. So that basically model the finish start relationship. So with that one, if we have concept design, that is one activity, and then when that finish, I can do the detail design. And that is another activity. And as you can see, this one we can model with the finish to start, and it goes from the right side of the predecessor to the left side of the successor activities when we model with the each activity at one node at here. And this relationship, in fact, that is the FS, finish to start relationship. So it means the predecessor has to be finished before the successor, in this case detail design, can start. That is the finish start. The other relationship that we are talking about is finish to finish. What does that mean in here? Let me see in the synchronous sections or in the face-to-face class. The class start at 8 a.m. or 1 p.m. or things like that. However, if the faculty will not start, then the student will not start to take a note. Things like that. So as you can see, that is start. And then we have a finish to finish. If you think about it, look at your the ceiling of a classroom or your office or things like that, and you can see we have a ceiling and we have the light fixtures. And relationship in that case, when you install that, it can be a finish relationship. So let me demonstrate that in here. So we have 2 activity. Example is ceiling, and then the the other activity is light fixture. So represent by one box. So when you install them, it may represent, you don't have to, there are two different trades, so you cannot use the we cannot do concurrently in the same room. So it may have something called finish to finish. It means that when you finish the last picture, you can close with the ceiling. So with that one, we can model that with the relationship finish to finish. And as you can see, go from the right side of the predecessor last picture to the right side of the ceilings, that stands for finish to finish. If you go from the right side, then finish, to the left side, then start. So that way you have the first finish start. And if you right to right, then finish to finish. So in this case, light fixture is the predecessor and ceilings is successor, and it finish to finish. So it means that you cannot complete the ceiling first before you complete the last picture. You can do the ceiling, but when the last picture have to be complete everything, then you close out the ceiling surrounding the last picture. That way we can model with the finish to finish. And go back to the example that I say in the synchronous sections or the face-to-face class, even class start at 1 p.m. or 8 a.m. or 10 a.m., things like that, but it doesn't mean both faculty and students start at the same time. If the faculty not start give the lecture, the student will not start to take note or listen to the lecture. So that more with the start-to-start relationship. The third and the last one that we consider in this class, start-to-start. So I give it in here, and you can see in any synchronous section or face-to-face, if you have faculty, start class, then you can have students start to take note, to listen to the lesson, or play with the phone, whatever. So here the two. So in that, you can see start, then student can start. So it's not about finish to start, not finish to finish, but in that relationship, it go from left to left side of the activity. And in that case, that it will be start to start relationship. So from left of predecessor to the left of the successor, it will be start to start relationship. So those are the three dependencies that we are looking at. The last one that we want to look at is the lead and lag factor. How does that play in modeling project schedule? Let me give you one example here. If you have placed concrete and then you backfill, then you cannot place concrete and backfill immediately. Let's draw it in here. So we have placing concrete, and then you will have backfill. Backfilling, that's something you do in your project one, that you estimate for the placing concrete, for the foundation, etc., and then backfill after you finish that. So it, as you can see, it can be finish start relationship. However, if we only put the finish start alone in this relationship, there's some trouble in here. Finish start, it means backfilling, I can start immediately after placing concrete. Can we do that? Concrete, when you place, it still have a fresh like fluid. If you put the backfilling, the soil on top of it, it messes up with the concrete. So you need to wait some time for the concrete to get some strength before you do backfilling. Let alone compaction, it may change the structure of the concrete when it gets hardening. So with that, finish start cannot be model with yes, but we need to add a lag factor in there. I need to wait a few days. Let's assume I have to wait 3 days, and that call for lag, and that means that I need to add here 3 days, and that 3 days, you call it lag 3 days. That's correct. I need to, after completing concrete, I need to wait for 3 days before to do backfilling. So lag 3 days. And when it lags 3 days, we can also say that is lead, by definition, lead equal to negative 3 days. So the lead and lag is opposite. If it lead 3 days, lag negative 3 days. If lag 3 days, lead negative 3 days. Make sense? So here we have to delay the backfilling, the start of backfilling 3 days after placing concrete. Let you finish the placing concrete on Monday. You have to wait another 3 days. So you have Tuesday, Wednesday, Thursday. So you can start doing on Thursday when you do the backfilling. So 3 days waiting, lag. Or in the design of a building like household or academic 7 or any institutional building, office, etc., we need to have architectural design and we need to have engineering design, right? So here, let me see, architectural design, and then you have engineering design after the architectural design complete. Then if you wait that long, you need to have architectural design complete before you do the engineering design. Then the relationship here, as you can see, is finish start relationship. Architectural have to be finished before the engineering design can start. However, if that linear sequence, it takes a long time. You can say I can start engineering design a few months before I complete the architectural design, and that you can model with the lag and lead in this case. So I can start, instead of start architectural design finish in October, and then I start engineering design in November. I can start early. I can start 2 months early. Then 2 months early, it means architectural finish in October. I can start engineering design in August. So with that, you can model with the lead lag in this case, and that here is the become lead, right? You start early, so you have negative 2 months, and that from there is mean that we can have lag negative 2 months or lead plus 2 months. So that is the difference between the lead lag factor that we are talking about. So by now you know what are the relationship finish, start, finish, finish, start, start, and any of those three relationships with the lead lag factor. So let me go back to capture that in the PowerPoint slide. So finish to finish, it means activity A have to be finished before activity B can start, and that task A must finish before B can start. Finish to finish, it means that task A must finish before B can finish. So from right to right. Start to start, it means that task A can start, must start before task B can start. Student, faculty must start writing, take note, or start the lecture before student can take notes, things like that. So start to start from left to left side of the activities. Start to finish. This one, as you can see, like I say, it's not practical in engineering. Task A must start before task B can finish. So I'm not going to discuss this start to finish relationship, and you will not see that in your schedule. It's not practical in engineering. In terms of lead lag, in this case, A finish and then B can start, but it lacked 2 days. So we can say that it lacked 2 days because B cannot start immediately after A finish, but wait for 2 days before B can start. So that's why we say lack 3 days. Or we can say that it lead negative 2 days. In this case, just like the architectural design and then engineering design example that I showed a minutes earlier, this case, as you can see, B can start 1 day before A finish. Then we say it lead 1 day or lack negative 1 day. So that basically what we are talking about. And then in model, the relationship with the lead lag, I give you another example in here. So if you have placing concrete and strip the form, and that way you cannot place concrete and strip the form immediately. You need to wait the concrete to get some strength. And that's why we say that a 3 day lag, wait for 3 days before we strip the forms or remove the form. Or we can add one activity in the middle that is curl the time for concrete 3 days. And we don't have to use the lag factor 3 days in the schedule. But as you can see, if you use lag factors, it can save one activities from 3 activities. If you put that 3 days for the curl time, you just put the lag 3 days between place concrete in the form and strip form, like the first finger shown in this slide. Then you save one activities, because as I say in the lesson 21, one's real schedule can have 10,000 of activities if you're talking about the power plant or things like that. The other example, as you can see, for the relationship, in this case, you have 2 relationship, finish to finish and start to start of excavate footing and set form and place steel or rebar, that you do it in project 1 and that you will schedule that in project 2, which will be discussed in today's class as well for project 2. So this one you can model different ways: initial excavation, final excavation, initial setting forms for steel, so that you can, instead of 2 and have relationship that finish, start, you can poorly model that schedule with the finish to start relationship. However, you need more activities involved with the same nature of work. So keep that in mind, and you can see use more dependency, other than finish to start to make your schedule simpler in terms of the number of activities. Use lead lag also be able to reduce the number of activities in your schedule, that hopefully make your schedule less complicated. So that is the concept of dependency and lead lag factor.